Hi class, how are you today? Wow, that's a really complex answer. I don't really know how to respond to that. The learning target for today is to be able to simplify and solve with complex numbers. For the scale, you're 3 if you can simplify and solve with complex numbers. You're 2 if you can simplify with complex numbers. You're 1 if you can simplify square roots, which we've done before. And you're 0 if you cannot simplify square roots. Let's get started. Alright, so first we're going to talk about imaginary numbers. I is known as the imaginary number. So I is the square root of negative 1. Normally, you can't find the square root of negative 1. If you try to put that into your calculator is going to come back with an error. If you think about it, it's asking what number multiplied by itself will give you negative 1. Well, that doesn't make sense because a negative times itself, which is another negative, would be a positive. A negative times a negative is a positive. So there is no number you could square to get negative 1. However, in math, they come out to be actually pretty useful. There's a lot of good uses for imaginary numbers. However, they're not on the real number line. So we call them complex numbers or imaginary numbers. Complex numbers are a combination of imaginary and real numbers. So if we're just talking about imaginary numbers, the square root of a negative number, then we're talking about imaginary numbers. But if we start putting in real numbers in there by adding or subtracting, that's what we call a complex number. And we're going to delve more into that today. Alright, so an important thing to know about imaginary numbers is what happens when you raise them to powers. So let's say we have I to the first. What does that equal? Well, if we come over here and say, well, there's one I, well, it's going to equal I. And anything to the first power is itself. Now, what if we say I squared? What does that equal? Well, we've got I times I. I times I, well, you are multiplying that by itself. You're squaring it. If you square a square root, that will give you what's under the square root. The square and the square root will cancel to leave negative 1. Now, let's say we have I cubed. Well, that would be I times I times I. Well, the first two i's give you I squared, and then times I. Well, I squared is negative 1. And so negative 1 times I would give you negative I. Then, if I had I to the fourth, well, that would be times I again. And then I times I is I squared, which is negative 1. And then this I times I is also I squared, which is negative 1. So we've got negative 1 times negative 1, and negative 1 times negative 1 is 1. Well, now what if I said I to the fifth? Well, it would be times another I, and these first four i's give us I to the fourth, and then times I. Well, I to the fourth is 1, and anything times 1 is itself, so I again. And you'll notice, it's a pattern. If I said I to the sixth, we would get the same thing. we just did, and it would actually end up being -1. And I to the 7th would be -I, and I to the 8th would be 1, and so on. So specifically, those 4 will always repeat. We could go as far as we wanted to, and it would still follow that same pattern. So let's say I said I to the 25th. What you would do is say, okay, what's the closest number that is divisible by 4? The closest number to 25 that's divisible by 4. Well, that would be 24. So we could call this I to the 24th times I to the 1st. Right? When you multiply numbers or variables, you add the exponents. So 24 plus 1 is 25. So this is just 1 times I, or just I. So I to the 25th is I. Let's just do one more. I to the 258. I can go really big. What's the closest one that's divisible by 4? That would be I to the 256. And then we have 2 left over. So I to the 256 is, again, 1. And I squared is -1. So that'll give us -1. So I to the 258th is -1. Okay, so next we have simplifying square roots of negative numbers. We've done this before. We've simplified square roots before, except there weren't any negatives inside. So this is going to be exactly the same as it was before when we just simplified regular square roots, but there's one extra step. So the first step is the extra step, and that is we need to take out that negative. So we rewrite this as square root of -1. And then now we say, same thing we did before, what's a perfect square you can divide out of 27? Well, that would be 9. And what's left over when you divide 27 by 9? That's 3. Now, we kind of changed the order of this a little bit. So, what's the square root of -1? I. What's the square root of 9? 3. And we put that in front of the I. And then the square root of -3 is left over. Same thing we did before, but now we have I in there. And this is our answer. Now this next one, same thing, split it up. Take out the square root of -1. And then what's the biggest perfect square you can divide out of 100? Well, that's actually 100. So what's the square root of -1? That's I. And what's the square root of 100? 10. And that goes in front of the I. The whole number always goes in front of the I. The square root always goes after the I. And that's our answer. Again, same thing we did before. Now we just have the extra step of making the I in there. All right, now we're going to find the products of imaginary numbers. So, in the first one, just like we were multiplying variables, do the same thing here. So, -5 times 3, you multiply the coefficients first, you get -15. And then I times I, you add the exponents, and we say there's a 1 in each one. So I times I is I squared. Because if you add the exponents, 1 plus 1 is 2. However, unlike variables, you don't stop there. We found out what I squared is. I squared is negative 1. So this is really negative 15 times negative 1, which is 15. And that's the answer. That's it. In the second one, first we're going to have to pull out the I. So in each one of these, we rewrite it as I square root of 6 times I square root of 15, because we're pulling out the negative under the square root. And then I times I is I squared, and square root of 6 times square root of 15 is the square root of 90. And so what's a perfect square that you can divide out of 90? That would be 9. And what's left over is 10. And I squared is negative 1. So now the negative 1 drops down. Square root of 9 is 3. And times the square root of 10. And then negative 1 times 3 is negative 3, square root of 10. So it's the first step of pulling out the i's, and then just multiplying the square roots and simplifying down. Okay, so we've solved quadratic equations using factoring. Now we're going to solve quadratic equations using another method, the square root method. And this one's actually a bit simpler. However, it really can't fully be done without understanding complex numbers. So, solve for x just like you would if it was x instead of x squared. So, I know when we were factoring, we wanted 0 on the right, but in this case, we want all the numbers on the right and then x squared by itself on the left. So we subtract 256 from both sides, and that'll give us 4x squared equals negative 256. Then divide both sides by 4, and that will give you x squared equals negative 64. Then it's x squared, so to undo that, we take the square root of both sides. This is the key part of the square root method. So on the left, you get x. And then on the right, first, whenever you take the square root of both sides, you need to end up with a plus or minus. And then after that, you just need to simplify this. So square root of 64 is 8. And we got to take the square root of the negative, so I. And that's our answer. So the plus or minus is specifically because we took the square root of both sides. So if we went back and put this in for x squared, well, if it was positive 8i, then 8i squared is negative 64, and that would work. But if we had negative 8i squared, well, a negative squared becomes positive. And then, again, 8i squared is negative 64. And so both ways, we're going to end up with negative 64. So we need that plus or minus. I would also accept writing it as 2 answers, because technically that is 2 answers. So I would also take x equals 8i or x equals negative 8i. So having both of these answers would also be an acceptable way to write it. All right, and the last example I'm going to go over is solving complex equations. So if we have a complex equation, we can actually solve for both x and y in one equation. Usually we can't do that with real numbers, but if we have a complex equation, we can. And the reason is because the x everything touching the x is real and everything touching the y is imaginary. And so we can split up the real and imaginary part. So we're going to rewrite this. And so we're going to have 3x minus 5 equals 7. That's the real part. And then y minus 3i equals 6i. That's the imaginary part. So on the left, it works like a normal equation. Add 5 to both sides. 3x equals 12. Divide both sides by 3. And x equals 4. On the right, there's an I in every term. So we can factor out an I. So we've got I times y minus 3 equals 6i. And now we can just divide the I out because it's in both. And we're left with y minus 3 equals 6. Add 3 to both sides. Y equals 9. And so we've got y equals 9, and we've also got x equals 4. So we solve for both x and y by splitting it up, splitting the real part and the imaginary part, and then solving each separately. All right, now time for the sponge activity. I've picked the problem similar to each example I've done, and so on number 1, I want you to simplify the square root of negative 18. On number 2, I want you to multiply 3i and 4i and fully simplify down. Number 3, I want you to fully simplify I to the 31st power. On number 4, I want you to solve for x in the equation 4x squared plus 100 equals 0. And on number 5, I want you to solve for x and y in the equation 2x plus 7 plus 3i minus iy equals negative 4 plus 6i. That's it for this lesson. Once again, please make sure to take notes on the entire lesson, including attempting the sponge at the end. Please attempt each of these problems. Take a picture of all of it, submit it all to Google Classroom, and have a good night.